maybe we could also just start. You did that already. Awesome.
Recording
I
is
was going to
started.
say start recording.
It's all you.
Cool. Let's just give it a minute, and perhaps a couple of others will trickle in, and then we can get going. Maybe a very quick question before we start rolling. Do you have an estimate of how long your talk is time?
I aimed for 40 minutes
Awesome.
as per instructions.
No, that's great.
I'll try to stay within that time frame.
Oh, that's perfectly fine. I mean, we're also a little flexible either way. It's just so we have some time for discussion as well. All right. Oh yeah, I think a couple of more people coming our way, but maybe we can just get started and then others will tune in. All right, hello and good day, everyone. I'm Ujjwal Gadaraju, an assistant professor at the WIS group at the Faculty of EMCS at TU Delft. I also happen to be a director of the Design at Scale Delft AI Lab, and it's my pleasure to welcome you all to the very last talk in this third edition of the Academic Fringe Festival on designing at scale with human AI collaboration. We can harness unprecedented amounts of data using AI today. We can create opportunities to tackle several societal problems across a wide range of domains like health, well-being, mobility, productivity, and technology is playing a pretty big role in helping us crack a dent in many of these cases. To make AI useful, though, we need to find new ways to combine the creative powers of humans alongside the analytical capabilities of machines and computers. Well, while designing solutions and developing systems for social good, a key challenge lies in finding out how we can help designers, experts, and other societal stakeholders working together with AI to prepare, realize, and evaluate design interventions. How exactly can we design and reduce complexity of designs for large-scale social interventions? Well, through the course of this particular edition of the Academic Fringe Festival, we've been discussing these and a whole range of interesting breeds of challenges within the space. We kicked this whole thing off with Ben Schneiderman. We've had people of the likes of Chen Hao Tan, Joo-Ho Kim, Aaron Halfaker, Nitya Sambasivan. Most recently, we had Maunia Lalmas come and share some of those great insights with us as well. This week, I'm extremely thrilled to introduce our next speaker, Judith Redi, who will talk to us about user ML collaboration. I've had the good fortune once again of crossing paths with Judith in the past, in my early days as a PhD candidate while I was here in Germany. But I'm really looking forward to hearing more from Judith, who's now the director of data at Miro. And Judith leads the data science and data engineering groups in delivering data products that enable data-informed decision-making and intelligent collaboration for both Mironeers, as they're called, as well as Miro's customers. I'm extremely thrilled for Judith being here today because I can think of very few people who can really share the passion from the world of HCI alongside keen interest in the machine learning AI space. A past in academia is what Judith has to boast for. She has a PhD in machine learning as well as an assistant professorship at TU Delft, and she has worked for many years at the intersection of this machine learning and HCI space and has focused on modeling the quality of multimedia experiences. I can go on and on about a wide array of accomplishments that Judith has to show, but I'd much rather use this time to hear what she has to share with all of us today. So without further ado, Judith, thanks a lot for being here, and I'm looking forward to everything you have to say today.
Thank you so much for inviting me and having me. I'm going to share my screen. Is that okay, Garrett, now? Yeah, cool. All right. All right. Hi, everyone. Thanks again for the introduction and the invite. I'm Judith, and yeah, I had prepared an introduction about myself, but Ujjwal said it all already. So, well, just very quickly, I'm Judith, and what I like to do is try to at least build intelligent software products. My background, so I'm Italian, I come from Italy, I come from a very small town in the north of Italy, which is most known because of Olivetti and because we throw oranges at each other during Carnival. So two very weird things, I know. I have a PhD in machine learning. I worked as a PhD student in Genoa in Italy at a joint project with Philips Research, which at the time was building displays and was very interested in knowing whether we could predict what was the quality of the incoming image in the display so they could improve it. So it was really about, well, I guess you would call it computer vision these days, but back then it was a combination of signal processing and machine learning was not sexy at all back then. So that's also where I started getting connected to the Netherlands on one hand, but also on, I discovered my passion for the human side of all this. So if you need to predict how people perceive quality, you also need to know a lot about visual perception as well as them as users and so on and so forth. And that's where I started working really at this intersection, which brought me then after my postdoc to TU Delft. At the time, Evi was still in the tall building, which you can see there. I spent there 7 years of my life, did my tenure track there. At the same time, I was working with IBM. So Zoltan is also in the audience. Hi, Zoltan. Good to see you.
Hi.
We collaborated during those years, and CWI as well. And then at some point, I decided I wanted to try something new. At that point, actually, machine learning was a cool thing. And I reinvented myself first as a data scientist and then started building teams in the data science space. So I worked a lot in software companies, always with this focus on building features, intelligent features to make the product smarter. So what does that mean? And now Miro is failing me, obviously. Oh, okay. So let's talk a little bit about what it means to build software, and especially software as a service. That's the thing. I'm sure you're all aware of the fact that we don't install software on premise, almost not anymore. This is the new way of building software. It's cloud-based. You pay a subscription and you get your application, you get your updates basically daily or even more often. You don't need to wait 6 months for a release. It's typically multi-tenant. And that's, how we built. So Miro is software as a service, such as Zoom as well, where we're talking now. The question is, what do you mean, Judith, when you say you want to make it intelligent? And that's $1 million question. We could start debating on philosophy of AI and start talking about Turing, which is one of my favorite subjects, but not for today. The one thing that pops up very often when you talk about intelligence software, especially in the mind of CEOs, in CMOs, where M is for marketing, is we're going to automate everything. Intelligent software automates everything. Whatever the user needs to do, we're going to do it for them. They're going to be happy, which to some extent makes sense. But I would like you to focus on the face of Buzz here, that is the CMO or the marketing person. And sometimes it happens that this is the face of the user. And this is what I wanted to talk about today. There is actually a phenomenon that has been studied for a very long time in general related to automation, but as algorithms have become more popular in software, it actually has a name. Since 2015, it was created, it was called this way, and it's algorithm aversion. It does happen very often that no matter how good your algorithm is, even if it's better than humans themselves at performing a task, humans will not adopt it. They will have a negative behavior, they will have a negative attitude, they will just leave it alone and keep doing things as they want. And again, I can't do a full literature review, but there's really a lot of interesting literature around this. And it's something that sometimes you really need to keep in mind when you want to automate everything, because it may really make or break the intelligence of your software, and more importantly, the adoption and the delight of your users. So what are possible causes for algorithm aversion? Why would people not adopt all this automation that should make their life so much easier? There's many, and here I linked also a very interesting paper that reviews all the literature related to this. Very simply, there is a cultural part to this, that it's what is called false expectation. So from the Terminator onwards, there's a cultural skepticism towards what AI can do that can bring people to be very careful with adopting it. It can be also related to the lack of experience with AI that makes people think like, I don't trust this thing, or there's something behind it that I don't understand and I don't want to use. So the typical possible solution for this is algorithmic literacy. It's not something you can really do when you build software features, because you can't really give a course to users. Like we have 30 million users for Miro, we can't really get them to go through a full course on algorithmic literacy before they start using our features. So I'm not going to focus too much on that. The second possible cause is what was called lack of incentivization. So why should I use this at all? It happens very often that people don't find a good enough reason to adopt automation, because maybe like they're not in a hurry, or because maybe actually adopting it makes the whole flow, their whole workflow longer. So I can give you an example from my experience very quickly. At some point in a company, we were working on a churn prediction model. So something that would help customer support people knowing in advance how engaged users that were calling to ask for support were, and whether they were using our software at best or not, and how likely they were then to churn. So they could address them in a different way, maybe respond faster if they were not engaged enough. And we built this beautiful model, very accurate. We built a dashboard in Power BI to help them visualizing these scores. And guess what? Nobody used it, because simply customer support specialists, they were working out of Salesforce, and they didn't feel like just going all the way to another tool to check this score. They just said, okay, I'm going to trust my gut feeling and it's going to be great. So the solution there, that's what behavioral design means, is to think about the workflow people and integrating it and integrating the ML into that workflow. So what we did to solve that situation was to actually create an integration between our algorithm and Salesforce, so they could see in Salesforce directly this churn prediction score and then do the actions as they should have been. And then there are two big things. One is lack of decision control. Whenever you introduce an algorithm that does something on your behalf, you are removing control from the user. And in some situations it's acceptable, in other situations it's really not. And that's where you need to really think in terms of human ML interaction, the human in the loop decision-making framework. And I will go through a case, like one more in detail into a case of how we did that. And the second part is when the algorithm, let's combating intuition, it's kind of like you feel like it's outsmarting you. So you're like, no, wait, this is my expertise. So instead of feeling like this is helping you, you feel like something that is threatening to you, and you are not willing to give up to an algorithm, and therefore you start looking into like, well, you don't adopt it. And to be able to address this, you need to actually work together. And that's another, if you want to still a human in the loop, but it's really about collaboration with the users to make them feel like they're augmented rather than replaced. And I'm gonna go through another more recent case for that. All right, so let's dive into the first case. And it's a tale of trading off some efficiency for a bit of control in bookkeeping automation. So this is from my time at Exact. Exact is a company that is actually closer to you guys than to me because it's on Delft campus. It is market leader for bookkeeping software and accounting software for small and medium enterprises in the Benelux. So it builds all the software that helps, especially small entrepreneurs, keep their books in the right shape, so they can, well, spend at least time as possible on bookkeeping and do more on business. Having said that, bookkeeping is not necessary. Then again, maybe in the audience, somebody loves bookkeeping. And in that case, please forgive me. But most people I talk to, including accountants where I was working at Exact, were like, yeah, that's not the most fun activity. And yeah, it's something that you need to do by law because it's mandatory to be able to pay taxes. And it's highly time consuming. It can take up to 2 working days a month for a small, medium enterprise, for a small enterprise. And if the small enterprise is a single entrepreneur building their own business, this is really a lot of time. So we were wondering, what can we do to help people streamlining this? And guess what the answer was? Automation everywhere, obviously. Yes, we thought bookkeeping tasks tend to be quite repetitive. A lot of it is related to noting all the transactions executed by a company and book them into the right general ledger account. So in the right bucket of cost or expense, so that then you can reconciliate this at the end of the month to pay or quarter to pay your taxes. So this mapping of transaction into a general ledger is, well, essentially a classification task. And we thought, well, we can learn how to do it. So diving a little deeper into the specific problem context, we had the following situation. So whenever customers would make a payment, customers are customers. So let's say the entrepreneur or someone from a small, medium enterprise would make a payment with a company card, then this would go to the bank, obviously. And then we had built an integration between banks and Exact Online, which is the software product that we were building, and we wanted to automate this. And then the idea would be like, okay, then the software can immediately book the transaction in the right general ledger. So essentially from the moment the user makes a payment to the moment this is booked in the right general ledger, it's instantaneous and they don't have to worry. So basically they will have their bookkeeping all done, all the general ledger, all the accounts correct. They don't have to think about it. Let's automate everything out of it. Perfect. Amazing. How do we do this? This, as I said, this is essentially a machine learning problem because it's a classification problem. So despite the fact, and this is a bit of a technicality, but essentially in when you have your books, you have a schema that is the set of accounts you need to book your transaction on. And that's, well, in the Netherlands, obviously, everyone can build the schema they like. So that's very inconvenient because we cannot learn all the schemas of everyone. So one of the things we did was actually creating a first model that would map any schema of any customer into a general schema. And then we built a model that, given the description of a transaction that was coming through the bank, would be able to map it to the right general schema account. Just quickly, an example now. I'm not sure how many of you understand Dutch, but basically the typical, so the way these BAS transaction descriptions come in is this mix of machine and natural language, but there's still some semantics that you can extract from here. So here it says ABN AMRO, for those who are not in the Netherlands, that's a Dutch bank. And it says basically kosten, this is the cost for having an account in ABN AMRO. So any human who knows Dutch, so not me, that reads this would know that this is probably something related to costs for bank accounts, and would make this mapping. And what we wanted to do is to have the machine doing this mapping automatically. In the end, it was a 942 class classification problem. And we trained on, well, we had a history of 5 billion transactions to train on. Then we didn't need all of them, but we would have in general 30 million bank transactions a month, and we had the rolling data sets throughout history. So this was also an NLP problem. This is another example of how a bank transaction description could come in. This is parking in Delft. So what you wanted to do once again was to transform this text, map this text into an account. And well, we started treating it as a natural language processing problem. Essentially, our assumption here was if you can extract the semantics from this, then it should be relatively easy with a classifier to map it to the right account. So besides some cleanup, essentially the algorithm was built in 2 steps. We had first, it was before transformers, just to be clear. So we went for an old school approach that was first word embeddings and specifically fast text, and then an LSTM. Probably transformers are what powers it now, but I haven't, of course, I don't have access to the code anymore. But basically what we did was transforming every word into the semantic space and then feeding it to a recurrent model that would look at the sequence aspect of words and finally map it into one of the 942 classes. I'm not going too much into the details of the algorithms here, but I'm happy to answer any questions if this is interesting for anyone in the audience. So this was working fairly well. So as we were building this, we also said, okay, let's check with the users if this is something they would use. And guess what? The answer was, yeah, but this thing needs to be perfect. I cannot just blindly accept that this books transactions to any general ledger. And if it's wrong, then it's my problem. It's my responsibility. This needs to be really good. Otherwise, I will never use it, which is fair enough. So our beautiful idea of having from bank transaction to everything booked out the window, we needed to find a way to actually make, get the users to buy in and work with the AI to save them time and, well, become more efficient while still feeling they were in control. And the task was kind of lengthy itself for this specific problem, because being a classification problem, we had top 1 to top N accuracy that we could provide. And what we saw is that already with top 3 accuracy, we would get above 80% accuracy, which would be something that would be acceptable by users. So what we ended up building was a suggestion system. So in the software, when we were absolutely certain, like we had that 95% probability that an account was the right one, we would just give a suggestion to book it there. If we had more distributed probabilities, then we would give up to 3 suggestions. And what the users could do is select the one that was the most appropriate according to them. So they were still in control. So it was much easier in this case than just going through all the possible accounts and say, okay, this is the right one. But they were still in control, as in they could still decide whether which suggestion was the right one and override it in the end. What we also added was the smart allocation configuration, where we said, whenever you feel confident enough that our algorithm is good, just click here and we will book it automatically for you. And we saw that over time, actually, people started using this. So did it work? Well, we did some estimations. So what we know is that without this automation part, it would take about 15 seconds per transaction to be booked in the right general ledger. As we introduced these changes, it took up to 1 second to actually do the transaction. And if you think about 4.5 million booking suggestions used in a month by our users, then we ended up saving essentially across all of our customers more than 2,000 days of work a month. So, it was this, again, automation alone wouldn't have cut it. People wouldn't have used it. But in this case, people started adopting it and started trusting it more and more because we were keeping them in the loop and giving them back this little bit of control that, yes, did not make the automation instantaneous, but still considerably faster than what it would have been if it would have been manual, and helped them trusting the software. So this was example number 1. And now from more recent days, something from Miro, which is the company where I'm working now. And well, Miro is the software from which I'm presenting you this wonderful presentation. But what is it? It's essentially an infinite canvas. It's a digital whiteboard. It's a free form space where you can do essentially whatever you want. You can do your brain dumps, you can do these presentations, you can build content to share with others, you can actually collect a lot of input from others, you can run interactive meetings with up to 200 users. I mean, in the company, we use it for 500 users at the same time. Brainstorm, plan, retrospectives, whatever you need. And there's one very specific thing of Miro, and it's stickies. So this kind of post-its, we love them. We inside of Miro, but our users as well. I checked in the data warehouse, like on average, we're like 9 million new stickies are created every day. That's 6,000 per minute. We have 30 million users, yes, but still a lot of stickies. So what are stickies created for? They're created for all sorts of use cases. Like if you're doing a retrospective with your team, if you use Scrum, you want everyone, if you've ever done a retrospective in person, you will know that people used to write things on Post-its and then stick it on the wall. Well, we do this in a digital form. You can gather input from others. So for example, if you're running like interviews with users, customers, participants to any experiment you may be running, then it can be very helpful to have a way to write down your notes and then cluster them. Oh, wait, did I say cluster? Let me get there. In general, you collect, it's an extremely helpful tool to organize your content, but especially to collect input from large audiences. So this is an example of something we do at Miro when we have the company all hands. Imagine that it's like 1,000 people. It's actually more now. And whenever we want to collect feedback, for example, on how to improve the all hands, we just ask people, okay, write it there. And then you get all sorts of suggestions like, I don't know, give us more long-term updates, give us some numbers, give us some business updates, top win of the week, and so on and so forth. So this is all beautiful because the content creation is instantaneous. Then when the meeting ends, there's a poor person that organized the all hands that needs to do this manually. And guys, those were 300 stickies, and it can go much bigger. And it takes a long time to cluster these stickies to then be able to extract insights. Like most people now, we know that these are clusters, they want company updates, hear from execs and leadership and so on. But it takes a lot of work to go from this to something usable. So this action is called clustering. And as people in machine learning know, clustering is a thing that we can do. So guess what? We can automate that, obviously. yes, we can automate it. And this time we were like, hey, this is easier than bookkeeping because you don't need to be super precise here, right? Like it's going to be like super cool. We're just going to create clusters and it's going to be great. So once again, this is a machine learning problem. Again, it's a natural language processing problem because stickies contain a very specific version of natural language because they're not very rich syntactically, and they use all sorts of weird abbreviations, emojis, like lack of verbs and so on. So not all natural language processing out of the box work perfectly well. But essentially you can create embeddings out of stickies. We use universal sentence encoders because they're great, specifically when you deal with very short text. Happy also to discuss that. And then once you have those sentence embeddings, you can cluster them. In this case, we use agglomerative clustering because there's never more than 300 stickies per board. So it was reasonable to use something a little more computationally expensive, but which would guarantee good results. And there you go. You go from stickies to clusters and something that we can present to users. And yeah, so for example, this is something that we clustered with our prototype automatically. This was from inputs requested internally in the company, like how would you like your office to look like? So for example, we found a cluster that was related to food, something related to music zone, something related to a reflection space. So not everything was great, but it was already pretty great. And it was already quite helpful to start, clustering and put apart, create groups of reasonably uniform groups in terms of meaning to extract insights. So we were very happy with our automated clustering, at which point we said, okay, let's show this to users. We were smart enough not to implement the UI and we used wireframes. We used Bigmap for this, but we went to users and we said, hey, how would you feel if we were to cluster stickies magically like this? You would get the clusters done. And users were not exactly thrilled, once again. You're like, why? It takes so much time. One of the things they said is, I don't trust this. I don't know what happened. So I'd have to check the whole thing. So it won't save me time. Another thing, so we brought this also to meeting facilitators. So to people that would get other participants to collaborate on a board and then would manually themselves create these clusters to then explain to their participants what were the main insights. And they said something that is more related maybe to explainability, like, I don't know what happened, so I cannot defend insights, like if I don't know exactly why the algorithm came up with this conclusion. But one of the main messages we got there was, it basically removes my expertise. Like, I'm the facilitator. This thing is going to take away my job. They're like, oh, okay. No, that was not the intent. The intent was just to get you to have more time with your participants rather than just spend it moving stickies around. But yeah, we missed that. We did a second round actually, where we tried at least to compensate for these two messages, especially like, I don't know what happened. So we added some explanations. Again, this was a prototype, so it was not yet working, but before we would implement the explanations in AI, we wanted to know if it would help. It actually did not help that much. People didn't have the time to go through all the explanations. They would miss some of it. They would say it's not enough. In general, they were still skeptical. In general, the main message was still this one. It basically removes my expertise. Great. So what happened there was exactly this. They felt like we were taking over. Their added value is limited. We were combating their intuition. We were overriding their intuition. So back to the drawing board, we thought, okay, how can we engage them instead? And we really flipped the paradigm there. We said, okay, instead of giving them the cluster and figure it out, we thought about how would normally a person do it. They would start with picking a sticky and then look for similar ones. So we just said, okay, what if we just retrieve the similar ones? So they pick a sticky, we give them the similar ones, and then they decide which ones belong together. So it's sort of a recommender system. And when we showed this prototype, people were like, oh, that I like. Great way to start. It's going to help me sorting through a lot of stickies. Somebody mentioned literally an Amazon recommender for this. And they could choose to use it or not. They had the control part and they felt they were engaged and working together with it rather than having an algorithm overriding it. So of course, data scientists were thrilled because they had to throw away all the clustering stuff and go for a new solution. So this became more of a retrieval task rather than a clustering one. The semantic representation didn't change, but then we really had to think about what is good enough, how many of these stickies should we return, how do we define similarity, and so on and so forth. So we had to work, for example, with similarity threshold. Okay, here. With similarity threshold, figuring out what is the right point where we want to stop recommending. And then actually we figured out that people wanted to also have the choice to retrieve more stickies or retrieve less. So we had to build a whole dynamic threshold that given time, I won't go into details. But yeah, in the end, we were able to deliver something which you can actually try in your, well, if you have at least a educational subscription plan, this is already available. But I'm gonna give you a little demo. So what I did here was taking some of like these previous stickies that I showed and then mix them with some of the concept that I mentioned. So software as a service, as well as, well, automation and so on. And let's see how it works. So the first thing you need to do is to open the clustering application. You select your stickies that are already highlighted, you confirm, and then we select one, let's say top left, to find similar ones too. And here you will find the ones that the algorithm saying are more or less similar. So we can maybe find like this is the default option, but we can retrieve more, or we can retrieve less. And now we go with the default, and then we say, okay, remote work allowance makes sense with work from home. Remote working also makes sense with work from home. Working teams, maybe not so much. We release it, we gather all, and here we go. We have already our cluster, and we can call it work from home or remote working, whatever you like. No, sorry. And then you want to go to the next one. So I don't know, let's take Miro. Zoom, great. Slack, and well, algorithms and automation, actually. So well, we can also say, okay, let's gather these two. And now it's breaking, great. Oh, there it is. And we call it SAS, for example. And so on and so forth. And I can talk about this, and I like playing with this a lot, but basically, hopefully this is something that can help you also in discussions. One of the things that I like to do a lot when I work, when we have retrospectives with the team, is to actually have this process together so we can really discuss, okay, this seems like this is the theme. What can we talk, what can we say about this theme? Who wants to speak up their mind, and so on. So this was clustering. And this brings me to the end of the talk. So all this essentially to say that again, automation can help users, can help efficiency, and is typically very welcome and can give this delight effect, but it can also scare people off. Algorithm aversion is a thing. If you have, and you really should, if you're designing the next intelligent software or feature, you want to take it into account very early in your design cycle before you start building, to avoid what we did in the clustering case, that you build the algorithm and then you check whether it makes sense. Do it the other way around. Work with prototypes, go to users, try to understand what are their values, how they would interact with this. Would this be disruptive too much? Would they fit into their workflows? Would they adopt it in general? And how can you design around this? And only then you start mapping this into a machine learning problem. So these were, in general, my thoughts. Again, thanks for listening to me. I also should mention that this was obviously not only my work, or basically not at all. I have wonderful teams I work with over the past years in Exact and now at Miro. And yeah, I just do the talking. So thank you very much. Happy to take any questions.
Awesome. Thank you so much, Judith. That was a really interesting talk and a lot of very interesting insights into what's been happening, behind the scenes, because I definitely came across some, videos about the Miro clustering that were doing the rounds, and it's nice to see the process that led to this as well. Thanks a lot for sharing these insights. As we wait for people to probably raise their hands and ask a few questions, I'll set this one rolling with a question of my own. And this is related to one of the earlier works you were describing, where while you were working with the team at Exact, you had this smart allocation configuration thing that you unfolded. And I was wondering whether in that space, people actually started to seek explanations when these suggestions were popping up, right? So in this space of human AI collaboration, I'm also particularly interested in how we can we can leverage explanations, and I wonder whether there's room for creating explanations alongside these suggestions, and whether that can increase uptake rather.
In that particular instance, honestly, no. Explainability was never so much a topic, because they would just recognize whether something made sense. So the mapping was quite intuitive. So they didn't need any insights on how the algorithm, as long as the mapping was correct, they were good. They didn't have time. So again, this is a very repetitive task. Imagine that you have 1,000 transactions to book. You're not going to read all the explanation. You just hope they're correct. So if it doesn't make sense, you're just going to say, oh, this thing doesn't work. And if it does, it doesn't matter why it got to that conclusion. So in that specific case, not so much. In the case of clustering, that was more interesting. That is, because clustering has so many dimensions. So now we've only talked about semantic meaning, but like users, especially facilitators, would expect the grouping to happen also. Somehow a lot of people ask this, did you map by color or by participants who created it? And we're like, no, that's not the point. But they want to know these things. So something like, okay, this has been grouped based on meaning is something that we created. Something else that people are very interested in is knowing underlying topics. So that goes more towards explainability. So why did you group these together? Is because we see that they cover an underlying topic. So we're looking into topic modeling right now to see if we can add this layer of explanation to it.
Right, makes sense. And could you also probably, just as a follow-up, share some insights into what people mainly use Miro for? You've sort of acknowledged that through some of the answers and what you've been saying, but I wonder whether that could also somehow inform the strategies behind clustering, right? And it sort of speaks to what you just spoke, where you said, well, some users expect different things. So,
Mhm.
well, putting my education hat on, right, when I'm teaching HCI students about HCI at the bachelor level. In fact, in my course this year, I used Miro to show, allow them to use that as a whiteboard where they could do some affinity diagramming. I
Mhm.
wonder whether, for specific purposes like those, if you were to have, different strategies behind clustering that could help shape up some experiences.
So that's a great question, and it's also a very hard one. The nature of Miro is to be an horizontal product that caters for so many use cases that cross-cut. So just to mention, like the normal use cases are, well, retrospectives, diagramming, and so on. But there's people that, like, people plan their weddings on Miro. That's just to give an idea of the wide range of applications and use cases. So it's really hard to narrow it down, as well as obviously recognize what is the current use case of the board, because that's obviously it's a holy grail, but it's like very practically, it's really hard to train a model to recognize that, because we are blind to the text that it's in the board. Like we can use it for like the clustering, but we cannot use it as training data, obviously.
Right.
So that's a bit difficult to learn how to distinguish between use cases. And customers, because this is an infinite canvas, very often you see boards that start with something that is related to strategy and then include a retrospective board, and then go to planning, and then all of a sudden it's actually like a presentation to show all the results. So that makes it quite hard to disentangle the specific use case.
I can imagine this probably could also be an interesting problem for a solution of human in the loop, right? If you could elicit something from the users and then maybe train an algorithm to help understand what the use case is. All right, without hogging too much of your time myself, sorry, let me bring on Zoltan, I think was the first one with his hand up.
Hi.
Hi.
Thanks for the nice talk. It was very nice and accessible, as I remembered when we used to work more closely together. Thank you very much for it. I have a question. You might have answered it already partially, but I'm curious, following up on the clustering. I mean, when you were typing there, you actually labeled those clusters. Have you experimented with automatic labeling, or is this even legally okay, or are there data ways of doing it? And if it's possible, I would be curious what your intentions are about people's acceptance on these.
Automating labeling of clustering, or
yeah, so like you group them
Yeah.
together, you have a bunch of things in the same cluster, and then maybe suggest labels for how people should label them.
So this is related to the topic modeling that I was just mentioning. So that's definitely the next thing that users want. Would be really, really helpful. I don't know if automatic labeling, but again, maybe something more like, okay, these are the topics that we find in the board, and these are the stickies related to these topics. And then you're free to decide whether you want to link that group to that specific label or rename it. But that's definitely something that we're looking into right now. Once again, the full automatic labeling goes back to the problem of full automation, and people may be like, oh, why? So we need to understand a little bit better how to keep like that's feeling of control and collaboration, as opposed to we're doing this for you, but it's absolutely an important aspect. Yes.
Thanks.
Thank you.
Next up, I think we have a question from Gaula.
Yeah, so hi, thanks for your wonderful talk. So I remember you mentioned the example of the bookkeeping, and you reached maybe around 80% accuracy with the top 3 recommendations. So, but I guess, so actually the employees, maybe, I don't know the employees from any company, but I guess humans would have better accuracy on the jobs. So my question would be, so when you provide the recommendation list, do you observe that the accuracy has some drop or like say worse than the human only case?
So that 80% was compared to human accuracy. We didn't, not for this project, we didn't really make a comparison of human accuracy and algorithmic accuracy. What I didn't mention here is that on top of this, so this was just the performance of the machine learning model, but on top of this, we had also some very basic logic that would address most common cases and that didn't need a learning machine for that. So that brought it very, very close to 90%. We didn't look into, like, we didn't quantify what would be human accuracy. We did it for the other experiments, not for this one specifically. But in general, we knew that like this, so what we did monitor in production was how often people would change the labels that we suggested. And again, the 80% accuracy was confirmed. So yeah, what we saw in training was also with live data. So they had to change about 20% of what we suggested.
Okay. Yeah. So one more question about this case. So what if, say, with the recommendation, maybe the workers or the employee won't try to find answers themselves. They try to just pick up one answer from the recommendation. So in that case, maybe say we have the benefit of reducing maybe the working load, but we lose some accuracy. I guess this may be a possible case here. So if this exists, how do you say plan to deal with the potential error case lead by this collaboration? What if you find that this may lead to some maybe performance drop or something?
So that's exactly why we designed it in this way. So depending on the structure of your general ledger and the nature of your transactions, our algorithm may be more or less accurate. So if you user find through experience that it's accurate enough for you to trust it, you can go for the fully automated way. But until then, you're free to actually override it whenever you want or use the suggestions. And that's where the user stays in control.
Okay.
So that's exactly like the conceptual mistake we made at the beginning, and that we reverted with a different design.
Okay, thanks.
Thank you.
Thank you, Gala. Next up, we have
Yes.
Kola.
Yes. Thank you very much. First of all, yeah, thank you for the talk. Very, very interesting. I had two small related questions regarding the clustering use case. One of them actually, we've kind of started hinting at it. Like as you mentioned with post-its, the difficulty is that people like use a lot of like acronyms or, you know, don't use verbs and all that. Do you think it would work to have some sort of an approach to kind of have it kind of personalized with kind of the user in the loop somehow? Because I guess, you know, acronyms within the same domain, for example, might repeat. So if the user can give some input regarding the domain somehow, or across boards of the different users or something like that, basically, could that lead somehow to a more interactive and a more somehow personalized clustering approach?
So the answer is, in general, yes. I think it depends on the use case. So if you're a researcher, for example, that elicits input from, I don't know, 20 people and has 300 stickies to sort out and works always in the same domain, then you may feel like, okay, I'm going to train the algorithm myself. I'm going to put this input in because it's going to save me time later. If you're a facilitator in an online meeting that maybe is 1 hour and the clustering should take 5, you don't want to have this type of interaction because it's actually going to be more expensive. So we're back to the use case point. It really depends. One thing you could consider is to try and train separate models. So maybe have separate embeddings or fine-tune embeddings on corpora that are specific to a customer. But then you need them to agree to it.
Yeah,
That's
exactly.
one of the problems. And
Yeah,
the other problem is
that's
that from a deployment point of view, so from an MLOps point of view, it's a nightmare to maintain all those models. And it's also very expensive from an infrastructural point of view. Because you need to store them somewhere, and the training, it's also non-trivial. You need to see if the fine-tuning works. So at the moment, the business case was not strong enough to go that direction, but it could be that for some specific customers that are maybe bigger in the future, we will look at.
Yeah, so it's kind of an approach that is it works like good enough for most, basically. Yeah, cool. Thanks a lot. Oh, and maybe one more small thing. I noticed that in the clustering, it was possible to say like remove suggestion or something like that. Is the information somehow, does it somehow go back basically to the cluster evaluation, or it's kind of left to the case by case?
No, for it would be really nice, but it's a very
again takes, I guess, too much
problem there.
Yeah.
That is that again, all the training and experimentation is done in an environment that, and rightfully so, is not the production one. Otherwise, the infrastructure people would kill us. And but then, like, you can't get customer data out of the production environment, and the customers will kill us. So we don't have the feedback loop. We're looking into ways to do something that is secure and compliant to the customer wishes and delivers more value, but it's not a straightforward solution right now.
Cool. Thanks a lot.
Sure.
Judith, I've got another question of my own while listening in onto all of this. I was wondering whether you have any metrics or measures for reliance on these new features that are being introduced as your user base grows, right? So if you take clustering as an example again, do you actually try and analyze whether the individuals who are being exposed to the potential of using clustering but choosing not to? And if so, what exactly are any insights, if you have some, on why people choose to go that way or not?
We have that set up partially. So we're looking at the whole funnel of adoption. I cannot disclose the numbers, that's why I couldn't add them here.
Sure.
But we're looking at the funnel of adoption. What we see right now is that actually the design is still somewhat cumbersome. It's something that we're trying to improve further on. But yeah, we have metrics in place for everything to track success and adoption, especially. Yes.
Interesting. And would you be able to say anything about trust in general, or is that something that you're implicitly trying to understand through user behavior?
We could do more for sure in that direction. What we can track is the moment we suggest a group of stickies. So you select a sticky, like from that moment until when people push the gather all button, almost every time we select somebody selects a sticky, they will gather them all. So the suggestions seem relatively good, and there seems to be enough trust for people to say, okay, these suggestions are good. I'm going to gather all these stickies together and put them in a cluster. So the conversion there is pretty high. We're still like trying to drive more adoption to have more people using it.
Nice. Okay. Just being, again, hogging the fact that there are a couple of minutes left. If I can squeeze in one last question. Thank you. Thanks for being gracious again with your time, Judith. So we've sort of talked about how explanations, through one of your earlier examples could fit in depending on the context that you're using in, right? And we know from the general discourse on HCI and human-centered explainable AI that it really depends on the context and the task at hand, the extent to which any explanation could actually be useful. I was wondering whether you have any insights to share on that front. Do you, for example, see any potential of using explanations to somehow inform adoption? If so, are there any desirable notions of what a good explanation would be in this context?
As I said, so we haven't pursued the explanation path that much because when we prototyped it to users, it was just like something they wouldn't look at. So to an extent, like finding solutions to make more transparent what's the reasoning behind the setup, like the group that you created, is something that could be helpful, and that goes towards the more topic modeling part. But explanations per se, again, even just by prototyping without even building something that may or may not work, people were just not reading. So that gave us a strong indication that this in this context, it wouldn't be helpful. Where it could be helpful are other applications. For example, like another thing that my team did is if you pick a template, there's this for you section that recommends the right templates for you. I don't know if you see my, okay.
Yeah, we do.
So here is where maybe it could help to have some explanation, explain like why, for example, a mind map, or why the sticky packs, probably because it's the one that I use most often anyway. But this type of like, every time you go into personalization, I see a lot of options for explanation. In the case of clustering, not so much in everything. So one of the things we learned also for automation is that it needs to be subtle. It doesn't have to be like this wow effect. Yeah. So if it's something subtle, it should be something that just works. And people don't have to go and look for an explanation for why it happened. So that's a bit more how we're looking at it.
Yeah, that makes a lot of sense. Great. I'm looking around to see if there are any final questions for Judith. Otherwise, I think I'm speaking for all of us here when I say that we're really happy and thankful for your presence over here, Judith. Thank you so much once again for making the time for all of this. It was lovely tuning into this. And for everyone else who's here, well, this does wrap up the third edition of the Academic Fringe Festival. I must say it's been an absolute pleasure bringing all of this towards you all. And this wouldn't have been possible if it wasn't for our exceptional speakers, Judith, including you. Thank you once again for being here. I hope to see all of you again when we have the next edition of the Academic Fringe Festival. Well, until then, I think this is it for now. Once again, thank you, Garrett, for being an able hand in supporting all of this, and everyone else for sticking around and being here for many of our amazing talks. Thanks, Judith. Thanks, everyone. Have a lovely evening.
Thank you. Thanks for this initiative.
Take care. Bye.
Thanks. Bye.